Welcome to the, shall we say, penultimate Friday video lecture for Met 103. We'll keep things pretty simple today, as I understand there's definitely a lot going on these days, and we'll try to keep things pretty simple from this point on out. So, again, between the two classes, two sections of the class, we ended up talking a little bit about the tracks, the general motion off to the west as they work their way through the trade winds, and then the curvature northward as we start to see, especially here in the Atlantic, as well as out in the Pacific, and then the relatively few storms that we see in the southern hemisphere, but again, some of these can still be quite notable in nature. And then we talked a little bit about where these storms form or where they hit in the United States. Again, the fact that you're going to have areas that are more exposed to these features see a greater return period, meaning how frequent they're going to see a hurricane. So areas such as southern Florida, areas off the outer banks of North Carolina. You can see, though, that some other areas that are more protected, say, areas such as South Carolina or up around the Delaware coast, maybe a much lower return period than some areas that are a little more exposed. And then, yes, this doesn't mean that after a storm hits, you get a big free period with nothing, as we have seen across Louisiana over the course of 2020. Again, recognizing the peak here, we have June, July, and August on the left, September, October, November on the right. And again, this big peak in September into October, and you can see the track down there in November, which is interesting as we still keep an eye on Eta. I encourage you to take a quick gander at where we're at with Eta whenever you decide to look at this sequence of slides. All right, let's move a little bit into the structure of tropical cyclones. Again, understanding we're moving from a depression up through a tropical storm and potentially to a hurricane or even a major hurricane, and we'll get into that eventually. Tropical cyclones in general are going to be notably smaller than your mid-latitude cyclones. That does not mean that we can't get very large tropical cyclones, such as Hurricane Katrina. As I alluded to in class on Wednesday, Hurricane Andrew, a powerful Category 5 hurricane, was actually a very small, much more compact than even a typical tropical cyclone. But regardless, these are smaller in nature, and you can see a number of the features on here. Spiral bands, eyes, and eye walls that we're going to get into shortly. Here we would have a tropical cyclone in the northern hemisphere with that counterclockwise flow that you can even just see with the bands going on in the system. So the eye of the hurricane, something that's talked about quite frequently and for very good reason. The eye, again, is the center of a hurricane. Not all hurricanes have a distinct eye. The more pronounced the eye, the typically means that you have a more intense hurricane. So even though we didn't get into great detail on it, Hurricane Eta, for instance, as it was moving towards Guatemala, was actually one that had a very tight, almost 8 to 10 mile wide eye. And the fact means that when you get these more pronounced, more compact eyes, you often have just an incredibly strong machine at work, and these oftentimes signify your stronger hurricanes. It is true that inside an eye, these winds are generally speaking very calm. It is quiescent. It is, well, to be honest, quite eerie, because if you are in the eye, you have inevitably been through the eye wall. And so if this is a strong hurricane, it does mean that you oftentimes are going to have significant damage already have occurred by the time you're in the eye. It is, for forecasters, a very important point to make to always be careful if the eye of the hurricane is over, because it means that you are going to again be impacted by the eye wall, which we'll talk about shortly again. Lowest pressure is going to be found in the eye. Weak subsidence, but you still have some sinking motion in this area. Few clouds. Again, if you start to find vertical wind shear in a hurricane, these ingredients that are not good, that break up, you start to blow clouds over the eye, and that effectively is going to help to weaken the hurricane over time. But again, here you can see that this would be an area with the eye. Very low pressure within the eye. You see this intense gradient in pressure, and that's going to help to affect this eye wall. And if you look closely, you can almost see again the stadium effect. If you say down on the field of a stadium, it would have like this kind of tilt, this slope going outward into the eye. Very beautiful feature of a hurricane. Again, we typically do not see eyes until we reach hurricane strength out in the Atlantic. but we can start to see some ill-defined eyes with some of our stronger tropical storms. Here you can see a cross-section, and the cross-section of a hurricane is a little on the confusing side, and it's not something that I really want you to get caught up on. I want you to understand the basics and remember the basics, but I don't want you to get flustered about exactly why it is the way it is. So I did mention the other day that one of the big differences with the hurricane or tropical cyclone versus a mid-latitude cyclone is the fact that they have this vertical stack. They don't want vertical wind shear. You don't have a tilt with height like we see with a strong mid-latitude cyclone. Remembering again that as we lose that tilt with height in a mid-latitude cyclone, you get to the point of an occlusion, and that's going to be when they weaken. Here, though, you can see that the eye is basically stacked straight up in the vertical. You can see the rotation here near the surface is going to effectively mimic what you see with a low pressure system. This counterclockwise flow here in the northern hemisphere, spiral up with the eye, but then you know up top you actually have this feeling of high pressure. This feeling that you actually are blowing air outward from the center of the hurricane. And so again, this may feel a little weird up here, but understand again the general basic difference between a hurricane is this vertical stack nature and the idea that you have a low pressure at the surface and you have this outflow pushing air away as you get higher up. You can see though here with the eye some of your intense storm action. Again, this is a schematic, of course, right near the eye and the eye wall. The schematic here is designed to show that as you move further and further away, you get these locations with rising and sinking and rising and sinking motion, maybe a little weaker as you move further away. Doesn't mean that some of these spiral bands in and of themselves cannot be intense, but generally speaking, almost always the strongest winds are going to be located very close to the eye of your hurricane. And so the eye wall is the focal point for many, many things related to hurricanes. It's going to be the ring of strongest winds related to that pressure gradient, extreme pressure gradient, the trace that we showed in class on Wednesday. Heavy rainfall can also be found in the eye wall, but usually the winds are going to be what you are most concerned with. Again, that pressure gradient where you have extremely low pressure in the eye. Not that the pressure is high if you get shortly outside the hurricane, but it's rapidly increasing. And so that responsive air is going to produce the very strong winds. One of the things that is notable about a tropical cyclone is the fact that you are really going to focus on the motion of your storms. You're going to look to the right side relative to the motion. So in other words, let's picture a hurricane that's moving directly westward right towards Florida. In fact, I'll even try and make a little arrow. I think it's supposed to make a little glow here. And so if I move my arrow like it's moving towards Florida and my storm is rotating in a counterclockwise fashion, it means that if it's moving from the right side of my screen to the left side of the screen, this right side of the hurricane, the top side of your hurricane, is going to be where we add the motion of the storm to the actual there's a little glow there. Okay. Add a little motion of the storm to the hurricane speeds themselves. So say I have a hurricane with 100-mile-an-hour winds that's moving 20 miles an hour. It means that this right side of the hurricane is going to have winds as though it's nearly 120 miles an hour. Mind you, that does subtract away on the left side, so you might have winds that feel like 80 miles an hour. And maybe we'll take a moment in class on Monday to show this a little bit better. So we have a short video here to show about Hurricane Hunter Irma in flight.
Rated to a Category 5. As you can see, this image hasn't really changed much. It's a little old and hasn't changed much over the last several hours. It's a strong storm. It's intensified slightly since North 4-2 left.
Through some little bits and pieces to get Hurricane Hunter flight storm measurements. And these are extremely critical in our understanding of what is going on with the hurricane. There are a number of people, in fact, that are taking of the measurements. One is the room, they look at drop sound, into the hurricane, measure pressure, in 5 seconds. see the spiral nature here. Again, the stadium effect. These areas of clear sky here near the eye. All clouds surrounding them in the eye. Relatively peaceful. Portion of flight again, even though I fast forwarded, you saw how bumpy it was earlier on.
Something I can go back to over that way.
Ground and close to the eye.
Well, I don't know if you heard. They were like, "Hey, are you good?"
Again, just a little bit of an idea of what it might be to fly into a hurricane and appreciating the eye and then the eye wall, where even early in the video you saw how, well, chaotic it was to be able to fly into that region of a hurricane. And so again, keeping into account where we have this high pressure aloft creating the subsidence, the helping in the weak sinking motion to keep the area in the center of the hurricane clear, rising motion in the surrounding bands in the eye wall, and that's going to flow outward again, venting effectively your hurricane. Very strong pressure gradient at the surface near the center is going to create those strong winds in the eye wall. And so again, understanding the schematic is an important thing to look at to really appreciate the structure of a hurricane. So here, this would be Rita. This would have been the hurricane that occurred about a month after Katrina. Rita at this point was effectively moving towards areas here in Texas. Again, Katrina having hit more out here in Louisiana. So near the center, you can see the eye of the hurricane, maybe a little bit of cirrus blow-off, kind of obscuring bits of it. But the point being, you can see some bumpy clouds here, I see. Basically some rising motion, tense convection, showing these bubbling cumulonimbus clouds. And you can even see other ones that would be associated with some of your spiral bands here and there, just intense convection. And so outward from the eye wall, we deal with spiral bands as well as outflow. Spiral bands are effectively additional thunderstorms that are feeding into the eye wall. But spiral bands can extend hundreds and hundreds of miles away from the center. Spiral bands are going to be areas in which we do see heavy rainfall at times. We may actually see some spiral bands produce tornadoes on occasion. Again, tornadoes associated with hurricanes are typically not strong, as we'll talk about here shortly, but still something that we do have to consider. Outflow aloft helps to lower the central pressure, helps to vent the storm, helps to keep motion. Basically, again, the idea that this hurricane is an engine that's just churning through as long as we keep the ingredients at hand, and outflow helps to promote a strong hurricane at times. Again, one of the things that is critical as we look at hurricanes and try to understand them, as well as understand their strength and their trending either upward or downward over time. The satellite imagery here is a hurricane out in the Pacific with TRMM, TRMM, Tropical Rainfall Measurement Mission. Again, what we see here again, some of the colder appearances going to be right around that eye wall that extends up, but you can see even some of the spiral bands where you get deep convection associated with portions of the spiral bands here. For instance, in this upper right image, you can pick out where some of the stronger convection would be, and some of it's actually outside of that eye wall. So let's take a couple more moments in this video, and then we'll be done talking about the hazards. We'll finish off hazards and then talk about the Saffir-Simpson scale before we work our way into global climate change next week. So one thing is, it is commonly thought, and for good reason, that the winds associated with the hurricane are always the most dangerous and deadly force. In reality, storm surge, a wall of water that gets pushed inland ahead of an approaching hurricane, can oftentimes be the most damaging part of the storm. We'll talk about in Katrina, even though it did have intense winds, as it made landfall in Louisiana, the amount of water, both in terms of rainfall as well as pushing inland with this storm surge, were actually responsible for the extreme number of fatalities that occurred with the storm. And so again, thinking back to that uh, forward motion, we're really going to focus on the front right quadrant as it pushes the water ahead of it. Again, remembering how much power, how much wind is associated with a hurricane. It's basically taking this water, pushing it onshore, then we have to start worrying about whether or not it falls in conjunction with things such as high tide. But we can get storm surges that are many, many feet of water pushing inland. For 1970, the vast majority of deaths were due to storm surge, even though we didn't fully understand storm surge. Remembering as we talk about surge, this is going to be a wall of water that's pushed out. We still have waves that are occurring on top of that. Again, as I mentioned, high tide can also be a factor. Front right quadrant is going to be where we see the storm surge most extreme. So we'll take another moment here, again, understanding that this is something that is not a significant issue in every hurricane. It is typically going to be a bigger issue with both stronger hurricanes as well as larger hurricanes. And another thing is that it is also heavily dependent on the shape of the land. In other words, if it's pushing the storm surge into, say, a bay where the water is forced upward because of more constricted geographical features on the shoreline, that's when the storm surge can even be more extreme. And so here, for example, where you might have a typical sea level, high tide, interesting looking house right by the water there, all of a sudden you start to add a 5-foot storm surge, a 5 meter storm surge, a 1 meter high tide, you get some waves on top of that, and it simply pushes the entire ocean, per se, onto land. And one thing water is extremely powerful. It may seem like, oh, it's just water, but when you have the force of an additional 5 meters, 10 meters of water pushing inland, most structures that are built are not going to sustain that type of force. So here again, looking at that right front quadrant, this should be a little graphic that helped here if we had a hurricane that was moving due north towards, say, Rhode Island. You would have an area on the right side. Increasing here would be a 100-knot hurricane, maximum sustained winds. Right side, we add that 25-knot forward motion to make it feel like more like 125 knots. Yes, we do take that off on the left side, and so this is why we often, when we're forecasting for hurricanes, become hyper-focused on where exactly it's going to land, because we really are going to watch out for areas where I'm circling right here in terms of some of the most dangerous setup. Again, looking at the coastline, we might be really concerned for an area here where we have an inlet, that storm surge really pressing it there. And so the right side of the storm, again, is going to be the area in which we're most concerned with the storm surge as well. Could obviously have significant damage from winds. These are going to be some images from Hurricane Andrew, the storm that I mentioned in 1992. You can see 2x4s impaling palm trees, pieces of plywood appearing again to go through some type of tall tree, and the damage that you see in the lower right basically mimics what you might see in a strong tornado. But rain is actually one of the other major threats. If you recall, on Monday of last week, I mentioned how as Ada was approaching shore, that we were most concerned with the amount of rainfall. Slow-moving system, lots of terrain, increasing the lift, and a copious amount of moisture in the storm. As you recall, we actually ended up with a major hurricane that almost hit Category 5 status, but when I was last looking, we still had areas that had exceeded 40 inches, more than 3 feet of rainfall in areas of Nicaragua from the storm. We'll take a little bit more of that look at that as we meet on Monday. But again, this is one of those things that freshwater flooding becomes a very big issue. I put the average there of 5 to 10 inches, but there is a significant variance, especially if you have storms that are large, moving slowly. That is another major factor, is the forward motion. You don't necessarily want a super fast storm when it's making land because of what we just talked about with the right front quadrant, but a slow moving storm means that these bands are just going to simply rotate over the same areas for an extended period of time. So here you can see Hurricane Francis making landfall in Florida. we'd be really concerned for some of these areas on the right front side of Francis, both for storm surge as well as rainfall with these bands coming in. But even well away, some of these spiral bands here far to the north, intense convection. And so this can be a threat very far inland as well. Here's an example from Hurricane Harvey showing that this was a strong Category 4 hurricane, but then it basically just meandered for a lot of days near the Houston area. And so you can see areas here where we had rainfall, large areas near Houston, over 30 inches, peaking at 60 inches of rain, which is pretty much unfathomable by most everyone to think of that much precipitation. Simply put, the slow motion. Note the difference in terms of where the rainfall was falling in relationship to the track of Harvey, mainly to the north, pushing this Gulf of Mexico warm air inland. You have areas up here, 30 to 60 inches of rain, and then you have areas southwest of Corpus Christi effectively experiencing no rain. Mind you, Texas is a very large state, but still, that's impressive to see how the gradient here of precipitation was with Harvey. Final slide for a day, because we've had a pretty long video. When we talk about other hazards, yes, the winds are definitely going to be a threat. It's the one that we think of when we think of hurricanes. In and near the Eyewall, we do get a lot of debris, so it is something that you don't want to go out if there was ever a hurricane coming by. Increasing with height, again, some of the winds down at the surface are going to be slowed down by our frictional force. And so that's one of the challenges that we have as we estimate winds within a hurricane, whether it be from a Hurricane Hunter aircraft or whether it be from satellite measurements, is when we see the winds, they're typically higher because we're measuring them at altitudes above ground level and trying to understand again how they may then correlate to winds that are being found at the surface when the frictional force is slowing things down. Winds do slow down after landfall. Again, this is where the gradient quickly decreases the lack of warm water. We lose those ingredients. And so we'll end this on Monday talking a little bit about how hurricanes basically die. And finally, tornadoes. Tornadoes are not something that we usually get too worked up with, but it is not uncommon to see tornado watches and actually a number of tornadoes. And sometimes these are going to happen with kind of marginal hurricanes. It doesn't necessarily, there's not a correlation, shall I say, between the strength of a hurricane and the number of tornadoes. We don't get more worried about tornadoes with a Category 5 hurricane than we do with a Category 1. It's the frictional forces associated with a landfalling hurricane that cause some of these tornadoes, but they're typically going to be your EF0, EF1 type tornadoes. All right, I've had this video go for a little longer than I had planned. Hopefully you were able to make your way through it, and we will finish off hurricanes on Monday. Take care, enjoy the beautiful weather this weekend, and get some rest. Stay healthy.